Hi everybody. Today I'm going to go over compounds and their formulas that contain ions. All right, there'll be a second video on this as well. So for the first one, here are our topics. Type 2 ions. We already had type 1 ions, which you'll see what type 1 are if I didn't call it that before. Defining ionic and molecular compounds. And 3, writing formulas for simple ionic compounds. So that's what we'll look at today. So here are a list of some ions from the transition metals that can have more than one charge. This is why they call them type 2 ions. Now, you notice though the charges aren't always the same. For chromium, we see 2 and 3. For copper, we see 1 and 2. Now, in order to name a compound that contains these type of ions, you must put next to the name of the metal, you must put a Roman numeral, which refers to the charge. Many people confuse this with the subscripts that you see in formulas. So you have to be careful with it. Now, we also have an older system where we use the suffixes OUS and IC. So OUS is always the higher. So IC here is the lower and OUS is the higher value. Now that's fine for chromium. You know there's positive 2 and positive 3. But for like copper, cuprous and cupric, the numbers are different. So you have to be careful. Most people just memorize these. And this is the way that they used to name these type 2 ions. And you can see the rest listed here. Aurous and auric, iron 2, iron 3 is ferrous and ferric, plumbus and plumbic, and stannous and stannic. Now you still see today the word ferrous used a lot. And they talk about any metal that contains iron is called a ferrous ion metal. All right, so what if we go back to a periodic table and use these? And what we see is that you can put those ions right in the spot where the symbol would be. So you can see that they're kind of clustered in here. Now, these are the type 1 metals. Type 1 cations because they're positively charged. So type 1 just means they have just one charge as an ion. But we see the others listed here. So no matter what, you have to come up with the symbol and the charge when you want to write formulas for these. You can either start from the very beginning with the neutral symbol and figure out what the charge has to be. Now you've done that before. Or you can go directly to the ion list. And that's what people normally would do. So we have, for instance, sodium, which is just Na positive. You notice the name hasn't changed at all. And we don't say the 1 because it's a type 1 ion, so it only has one charge. Whereas for ferrous and ferric, or iron 2 and iron 3, you have to indicate the charge. And then we have oxide over here, a common monatomic, meaning only one atom per ion, monatomic anion because it is a negative charge. All right, so compounds can be put into 2 different categories. We can have molecular compounds made of molecules. They all contain covalent bonds, and they consist of nonmetals only. So we can see hydrogen, oxygen. Now you might wonder, I thought hydrogen, which is in all 3 of these examples, was a metal. Well, hydrogen is actually both a metal and a nonmetal. It's kind of in its own family. It's very, very unique because of that. So here we're going to consider hydrogen to be a nonmetal. So we'll go over formulas for molecular compounds later in the course. Now for ionic compounds, they're all made of ions. We see sodium and chloride, potassium and sulfide. They contain ionic bonds, and the stronger those bonds are, the harder it is to separate the ions, which means the higher the melting points would be. Now you can determine, just by looking at the formula, you can know if a compound is ionic or molecular. If you see a metal in the formula, that means it's ionic. That's all you have to look for is a metal. Now let's take a look at ionic compounds. And here's an example I'm going to use is table salt. Now whenever we think about melting table salt, it dissolves very well in water, but it's very hard to melt it. Now, table salt, sodium chloride has a melting point of about 800 degrees centigrade. So one thing about ionic compounds, they are all solids at room temperature. There are no ionic liquids nor ionic gases. Now, if you took a look at a crystal of sodium chloride, it would be cubic in shape, And shape is indicative of different compounds. In fact, that's how people would tell what kind of a compound they found if they were doing some mining. If they knew the shapes, they could figure out the formula. But if you could take a look at let's say, just part of that crystal, you would see that you have alternating sodium and chloride ions arranged in what they call a lattice structure, crystal lattice. You can't tell by looking at the formula for sodium chloride how many of the different ions you have. All the formula tells you really is that for every sodium, there's a chloride. But the numbers could be in the billions and trillions within a spoonful of table salt. But whatever it is for the sodium, it's the same for the chloride. So let's take a look at some formulas now. I'll show you how to figure them out, then I'm going to give you guys something to do. The first one, what's the formula for sodium chloride? So the first thing we need to have is the symbol and the charge. So you can go and look them up, or I can memorize them. So I'm just going to give them right here. Sodium, +1, and fluoride is -1. Now all the compounds that are ionic, they have empirical formulas as their formula. That means the simplest ratio. So when you have an ionic compound formula, it means that you have the smallest number of ions, positive and negative, that will give you 0 for a total charge. So the total charge is always 0 in an ionic compound. So in this case, I just need 1 sodium and 1 fluoride because +1 and -1 gives me 0. So therefore, the formula is NaF. So we always write the metal first and then the non-metal, or the positive and then the negative. And we just say the name of the ions involved. So this is sodium fluoride, and that's the compound that contains fluoride that's in toothpaste. What about magnesium fluoride? So again, we have to look up the ions. Magnesium, Mg+2, fluoride F-. Now, total charge must add up to 0. So if we were to use just one of each of these, we would get a total charge of +1. So that's not going to make it. So we know that the formula is not MgF. It's going to be MgF2. Now, why is it MgF2? It takes 2 fluorides to give us a -2 to balance off the +2. So together, these guys are -2. Now, what about the name of it? You notice there's no 2 anywhere in the name. So you just have to figure out the formula from the name. So you cannot assume that it's going to be 1 magnesium with 1 fluoride. You have to have a periodic table, some list of ions with you. Now, why don't you guys try aluminum chloride? Now, I'm going to give you the charges. So here's aluminum and here's chloride. So you want to pause the video at this point and then come on back and check your answer versus what the real answer is. Okay, here is the solution to this question. So you notice that if I add +3 and -1, I don't get 0. So it's going to need more chlorides. Now, you never want to think of how many more do you need. You want to think, well, how many do I need totally? So I need 3 chlorides for each aluminum. It kind of look like this. And in this way, +3 and -3 gives me 0. So 1 aluminum and 3 chlorides will do it. So how do I write that in a formula? AlCl3. So that 3 in the formula is called a subscript. And we write the subscripts, it means actually, subscript means to write below. And a subscript multiplies directly to its left. It's always to the left. And it doesn't go beyond that 1 symbol. Now you notice that we don't write in number 1 as a subscript. Just by putting down the symbol, you mean 1. Right. Now there is a shortcut to do this. And here's the shortcut. If you take the number, it's just a number now, not the symbol or the charge, I mean. If you take the number of the metal, that's going to become the subscript of the non-metal, and the same thing here. The number of the charge of the oxide is going to become the subscript for the aluminum. You can just switch them like that. Now, when doesn't it work? Well, what if you were to combine lead +2 or plumbus with, let's say, sulfur or sulfide, which is 2 negative. If you were just to combine those together and flip those charges, you'd wind up with Pb2, S2. But this is not an empirical formula, so you have to reduce them at this point to just PbS. And that would be the correct answer, whereas this would not be correct. All right, now it's time for you to try some more. So here are 4 for you to try. I want you to write the formulas for them. Now, in order to do that, you have to have the symbols. So go back to your periodic table, figure out the symbols and the charges, write them down, and then combine those ions properly. All right, so you pause the video at this point in time, and then come on back. All right, so let me show you how we figure these all out. So here are the symbols and the charges for the ions. I wrote them all right above the names. So you can tell by looking at the first one, calcium chloride, that's CaCl2. You notice again, we're not saying subscript 2. Aluminum bromide, AlBr3. Magnesium oxide, MgO, not Mg2O2. Iron 3 sulfide, Fe2S3. Now, sometimes you can reverse these subscripts and come up with the charges. So how did I know to call this one iron 3? Well, if I were to take that 3 here for the sulfide, that would then come from the iron. And the Roman numeral then tells me what the charge is. So let me show you an example of that. So what if I have FeCl2 and FeCl3, and I'm asked to name those? So I'm going to use a Roman numeral for the cation if I can have more than one charge. So you have to remember that iron is like that. So here are my 2 formulas. So I'm just going to work out what the charge of the iron would be. I'm going to use an X to represent the charge of the iron. And then I'm going to plug in what the charge is for the chlorides. So for the first one, so the X represents a charge on the Fe. There are 2 chlorides, so that's 2 times -1 or -2. So the X is +2. Over here, it's just with a 3 instead of a 2. So we have 3 chlorides, that's 3 times -1 or -3. Therefore, the X is +3. So we have iron 2 chloride and iron 3 chloride. Again, would it be wrong if I just said iron chloride? The answer would be yeah. That would be wrong because it wouldn't know if you meant FeCl2 or FeCl3. Okay, what about this one? What is the name of PbO? Now, you might think, well, I don't know, lead, is that one of those metals? If you looked it up back in that chart that I gave you earlier, you'd see, yeah, that's true. So what do we have then? We have X for the lead. Look up the oxide, that's -2. Therefore, that's +2, and this is lead 2 oxide. Okay, that's the end of the lesson for today. I'm going to do another lesson on another type of ion.